This is a little bit more simple, two-step and just dimensional analysis in general for those of you who are struggling to kind of wrap your head around it with all of the extra metric stuff, okay? So like, let's say I have, I know that like on one hand, there are 5 fingers, right? Those two things are equal. On one hand, there are 5 fingers. And so what if I have like 35 fingers, right? 35 fingers, how many hands is that, right? Right now in your mind, you might be thinking, well, 35 divided by 5 is 7. And you're right. But you can't just write that because we're doing dimensional analysis. So this is how you would set that up. 35F, right? F is fingers. That's the unit I want to go away, so it goes on the bottom. Hands goes on the top. And then fill in the relationship. This is the relationship. So 1 hand, 5 fingers. Fingers cancels. 5 can go into 35 7 times. So now it's 7 times 1 hour. 1 hand is 7 hands. 35 fingers is the same as 7 hands, okay? Okay. What about something like this? I want to convert days to weeks, okay? 28 days to weeks. So I have 28 days. What's a relationship between days and weeks? Right now you're screaming at the screen, 7 days, Miss Miller, there's 7 days in a week. And you're right. You're so smart. So 7 days. Days goes on the bottom because we want it to cancel out. So it's 7 days in 1 week. Days cancels. Multiply across the top. 28 times 1 week is 28 weeks. Over 1 times 7 is 7. 28 divided by 7 is 4 weeks. 4 weeks. 4 weeks until Halloween? That's coming up. Okay. All right, how about this? This is a little bit trickier because it's a word problem. So the word problem reads like this. I am driving 100 kilometers per hour on my moped. If I drive for, I don't have a moped. If I drive for 2.5 hours, how far will I get? So I am driving 100 kilometers per hour on my moped, right? So this is the relationship between the two units. If I go for 2.5 hours, the question says, how far will I get, right? So what's the question asking for? It's asking for how far. It's asking for distance. So that means your answer is probably a distance. I mean, it is a distance. So your answer is in kilometers. So now you have a quantity and you need to convert that unit to kilometers. Do you have a relationship between kilometers and hours? Yes, you do, right there. Okay, so hours is on the top here. So I want hours on the bottom over here. How convenient, it already is. So I go 100 kilometers in 1 hour. Okay, hours cancels. 2.5 times 100 kilometers gives me, what is it? So 2.5, the decimal point is going to move 2 spaces to the right. So that's 250 kilometers, right? 100 makes 2.5 100 times larger than itself. And so that is 250 kilometers. Okay. Cool. Okay, I think this is recording. All right, hi. So we really haven't had enough time to learn dimensional analysis, so I'm making this video for you. I hope it helps. Okay, I'm gonna do a few of these from this sheet I have in my hand. I'm gonna start really simply with 30 meters to centimeters. A couple things that I'm seeing people struggling with is just setting up the problem. I'm seeing all kinds of stuff like 30 meters over centimeters, and then people are starting to just, you know, put question marks in there. Like, don't do anything with your setup other than this. This is all you do, period, ever. 30 meters. I've written my measurement. And then I like to envision that over 1. You don't have to write that, but I encourage you to, especially if you're struggling to visualize that these problems have a clear top half. That's the top half. And then they have a clear bottom half. That's the bottom half. Okay? I want meters to cancel out, right? I'm going from meters to centimeters. So meters cancels out. Centimeters will be what my answer is in, all right? And then I would need my metric conversion chart, which I've realized I didn't bring with me to this little video area. So I'm gonna go get it and I'll be right back. All right, here it is, okay? Some of us are intimidated by this, but this is how you use this. I'm going from the base unit, meters. Look, it has no prefix. It just says meters. There's no little c or k or g or m in front of it. I'm going from the base unit to centi. So I'm going to pick this one right here, base unit to centi. Now you can see it tells me the relationship between centi anything and the base unit. So 100 centigrams in a gram, 100 centimeters in a meter, 100 whatever, okay? So 100 centimeters in 1 meter, okay? Setup. Next step. Cancel out. Anything that is the same on the top and on the bottom, right? So that's in the top, that's in the bottom. Cancel. Now, last step, we're done. Multiply across the top, and then multiply across the bottom, right? So it's going to be 30 times 100 centimeters is 3,000, right? I saw the 3 zeros, so 3,000 centimeters. And then it's just over 1. So it's just 3,000 centimeters. And I'm done. Wasn't that amazing? Okay, moving on to something a little bit more challenging. Many of you before this class, or even in this class, haven't mastered or haven't become familiar with these metric numbers down here. And excuse my dirty nails. So nano, and then that little weird U thing is called micro, right? You can see that here. It says micro. And then pico is probably unfamiliar. Mega, right here. Mega is unfamiliar. And then giga. And this is a typo. It should be a capital G. Okay, so anyway, those are some ones you've maybe never seen before. So then when you see something like 67 microliters to nanoliters, all of a sudden you're already like, I don't know what this is, right? This is how you do it. 67 microliters, right? It's over 1. And then microliters goes on the bottom. We want it to cancel out. Nanoliters goes on the top. I'm looking at micro to nano, so I can see there are 1,000 nano in 1 micro. So 1,000 nano, 1 micro. And then cancel out anything the same on the top and the bottom. Multiply across. Multiply across the top, so 67 times 1,000 nanoliters. And then 1 times 1, so it's just over 1. All right. Okay, so now I think you should try to work along with me. So let's say you have 400 nanometers to picometers. Okay? So these are very, very small measurements. I cut a meter into 1,000 pieces, it's a millimeter. If I cut a millimeter into 1,000 pieces, it's a micrometer. If I cut a micrometer into 1,000 pieces, it's a nanometer. And if I cut a nanometer into 1,000 pieces, it's a picometer. Okay, so very small, measuring things like within the cell, molecule size, very small. Okay, so I'm going to set it up, and then I'm going to give you time to solve it. I'm just going to like stand here and do nothing for a second, or you could pause it. And then you should check what I did, okay? What you did against what I did. Okay, so 400 nanometers, we know that's over 1. Okay? Nanometers has to cancel out, leaving picometers to go on the top. My answer will be in picometers. Okay, I'm gonna give you a second to figure it out. Figure out how many picometers are in 1 nanometer. I'm sorry. Okay, so hopefully you've had a chance to look at the sheet. It kind of gave you a big hint. It's 1 nanometer and 1,000 picometers. Nanometers cancels out, so you get 400 times 1,000 picometers, which is 400,000 picometers. Okay, I'm just putting all of the zeros on there. That's like a trick for multiplying. Okay, so it's 400,000 picometers. All right. So I'm going to stop for a second and I'm going to make some more challenging videos. All right, we're back to the dimensional analysis Friday afternoon extravaganza. So these are going to be, this episode is going to be two-step problems, okay? So I will tell you the problems that I'm going to solve. I'm going to solve 3. I'm going to solve 1 completely straight through. I'm going to solve 1 halfway, and then I want you to finish it, and then I'm going to write 1 up there, and then you can either pause, or I'm leaving enough time for you to work on it without pausing it, and then I'll solve it. Okay, so you should work along with these. Okay, so let's do this. We're gonna go 20 centiliters to kiloliters. That's problem number 1. And then problems number 2 and 3, if you want to write them all down right now, just anywhere, we'll do 30 meters to micrometers, and we'll do 15 picometers to micrometers. Okay, so going to a smaller measurement and then going to a larger measurement. All right, so 20 centiliters. Can you see that? Yeah. To kiloliters. You can see here, centi, right? And then kilo. So we're going to need 2 of these, at least. All right, you could make it a 3-stepper, but don't do that to yourself. So if you can see, it's going to go centi to the base unit. Sorry, this is hard for me to like do the opposite. So centi to the base unit, and then we'll be at the base unit, right? Centi to base unit, and then base unit to kilo. Wow, I really can't like mirror myself. Okay, so centi to base unit to kilo. Those are the relationships that we are going to use. So I know that centiliters is going to cancel out. So that goes on the bottom, leaving the base unit, liters, to go on the top. I'm not done yet because my answer needs to be in kiloliters. So then I need another conversion factor Liters goes on the bottom, so it can cancel out, leaving kiloliters to go on the top. Okay? And at this point, what I really like to do when I'm starting to build up these conversion factors and have too much going on, I like to circle the unit that I'm going to have my answer in. So kiloliters will be present at the end, right? So now it's just a matter of filling in the relationships. Remember, you're looking here to find the relationships. There's 100 centiliters in a liter, and there are 1,000 liters in 1 kiloliter. So 100 in 1 and 1,000 in 1. Cancel out anything that is the same on the top and the bottom, including this 0, just one time. You can't take a 0 from here and a 0 from here. Okay? And then we'll multiply across the top and the bottom. So 2 times 1 kiloliter. You see that? You can kind of see that. 2 times 1 kiloliter over 10 times 1,000. So 1, 2, 3, 4 zeros. 1, 2, 3, 4. So 2 kiloliters over 10,000. Okay? This would simplify in this way. When 2 gets divided by 10,000, the decimal point is going to move 1, 2, 3, 4 spaces. Okay? The decimal point will move 4 spaces. The answer will only have 3 zeros, right? So the decimal point started to the right of the 2, and I moved it 1, 2, 3, 4 spaces. Boom. Okay? Or think about it like this. Whatever you divide it by, it has 1 less 0 than the base. Okay? That's just a little bit of a division trick. It has nothing to do with dimensional analysis. If you want to leave your answer like that, you can. You're done. Right? So that's how that works. Okay. Remember at any point that you can stop the video and re-watch certain parts. You can pause it, watch it faster, watch it slower, whatever you want. All right, 300 meters to micrometers. I already know that this is two-step because I wrote this, but this is how you figure that out. When you know that you're going to go from the base unit to micro, you look here and you see, okay, I can go from the base unit to milli, fine, and then I can go milli to micro. Great, so I need 2 steps. So, my meter on the bottom, millimeter on the top. Again, it's always just the opposite. 1 unit's on the top and you want it to cancel out, then you need to put it on the bottom. So micrometer over here, all right? Cool. So there are 1,000 millimeters in 1 micrometer. You get that from here. And there are 1,000 micrometers in 1 millimeter. Cancel out whatever is the same on the top and the bottom, and then multiply across. 30 times 1,000 times 1,000 micrometers. So that would be 1, 2, 3, 4, 5, 6, 7 zeros. Micrometers over 1. Done. Okay. I think I told you that I was gonna go slower. I forgot. I'm tired. Okay, so this one, 15 picometers to micrometers. Okay, again, you would check here. You would see pico to nano, nano to micro. Okay, cool. So you have it like this. I will pause for dramatic effect and for you to pause the video here, try to solve this yourself, and then restart the video to see how I did it and if you did it right. Okay, great. Now we're gonna do it. So picometers is over 1, remember, 15 picometers, the whole thing. Okay. Picometers goes on the bottom, nanometers here, nanometers on the bottom, micrometers on the top. That is the unit that my answer is in, micrometers, right? Right, we're converting from pico to micro. And then the relationship is 1,000 picometers in 1 nanometer and 1,000 nanometers in 1 micrometer. Picometers cancels, nanometers cancels, multiply across the top, the bottom, multiply across the top, and then multiply across the bottom. So 15 times 1 micrometer over 1 times 1,000 times 1,000, which is a million. Wow, cool, okay? And then if you're using the division trick I taught you before, remember, the decimal point moves as many places as there are zeros. Now, because this is a 2-digit number, it's going to move 1, 2, 3, 4, 5, 6 places. These 2 digits, that's going to give me only 4 zeros in front. Okay? If you need to visualize that, look, 15, the decimal point is there. 1, 2, 3, 4, 5, 6, and then you just fill in the zeros in between. All right? Work on your number sense. You're going to feel a lot more comfortable and fluid with dimensional analysis if you're comfortable and fluid multiplying and dividing by powers of 10. All right, that was 2-step dimensional analysis. You are very welcome. See you later. All right, welcome to another edition of dimensional analysis on a Friday evening. This one is going to involve multiple units. So like, for example, 210 kilometers per minute. Many people wonder, well, what number goes with minute? No number goes with minute. It's per minute. So in 1 minute, you go 210 kilometers. In 2 minutes, you go 420. In 3 minutes, you go 330. Okay? I think you get the idea when you consider the fact that if you really want there to be a number, the number's 1. 210 kilometers in 1 minute. Okay? Oh, we are converting that to megameters per hour. Okay? It's still just a 2-step conversion, but because there are 2 units, it's going to look way different. Okay? So megameters per hour. All right? So first, kilo to mega. Right? Kilo to mega, right up there toward the top. There's 1,000 kilometers in 1 megameter. So kilometers has to go on the bottom. Megameters goes on the top. There's 1,000 kilometers in 1 megameter. And then minutes is going to convert to hours. And you know that relationship. Right? There are 1 minute and 60 hours, right? 60 minutes in 1 hour. Okay, so you're all set up. Now all you need to do is cancel whatever's the same on the top and the bottom. Technically, it's dividing. It's not canceling. Okay, it's definitely not just crossing out, right? But if it's the same on the top and the bottom, you might as well do it now instead of multiplying everything out and crossing it out later. Got it? Okay. So kilometers cancels, right? My answer needs to have megameters, and there it is right there, not canceling out. Great. And then minutes cancels, right? Here, bottom to top, bottom to top. Remember, you're always just putting it opposite the unit that you want to cancel. Okay, so even though minutes started in the bottom here, that means minutes goes in the top up there. I didn't emphasize that when I first wrote it out. But that's the case, okay? And there's my base unit, hour. Not base unit, but my unit that's in the denominator. So now I'll go 210 times 60 megameters. And it's enough to just leave it like that. You don't have to do the multiplication for this. Over 1 times 1,000 times 1 hour. So 1,000 hours. Oh, and I probably had some zeros I could cancel. Great. So 21 times 6 over 10 megameters an hour. Okay, I'll do one more. 4,800 hours per joule to minutes per kilojoule. That's where we're going. Hours per joule to minutes per kilojoule, okay? Notice that, like, I don't even need to put a number in front of here to show you how to do this problem, right? It's really the units that are confusing and where to put them. And then filling in the numbers after that is the easy part. So you probably already picked up on that I always fill in the units and then the numbers. All right, so joules is going to have to go to kilojoules, so I know joules is going to cancel. So I'm putting it on the top. Bye. Okay, that will leave me with kilojoules. Okay, another common mistake. This is what students always do. They think, I need to go from hours per joule to minutes per kilojoule. So I'll put joules here. I know joules needs to cancel, but then, like, do I put minutes here? No, those aren't the same type of unit. So they can't go in a relationship together like that. Okay, opposites do not attract in this case. So joules is converting to kilojoules. There are 1,000 joules in 1 kilojoule. And then hours will go on the bottom, and it's converting to minutes. 60 minutes, 1 hour. Okay. And now this will be 4,800 times 1,000 times 60 minutes over 1 kilojoule.